This video covers topic 19.4 over adding and subtracting radicals. The Bell Work has asked us to simplify the following radicals. So while I have this open, I'm going to double check in my calculator that none of these work out nicely before I simplify by hand. So the first one does not. The second one does not. And the third one does not, which means I have to simplify all of them by hand. So the square root of 190 can be broken up into 19 and 10. Well, 19 is a prime number and cannot be simplified further. 10 is broken up into 2 and 5. And 2 and 5 cannot be broken up further. So the square root of 190 cannot be simplified any further, which seems crazy because 190 is a really big number, but no matter how you slice it, there's no common terms, no pairs that you can take out. So next we get to 75. 75 can be broken up into 5 and 15. 15 can be broken up into 5 and 3, and 5 cannot be broken up any further. So we have 3, 5, and 5. We will bring a pair of 5s outside and leave a 3 under the square root. (98) is divisible by 2, and 2 times 49 will get you to 98. 2 cannot be broken down any further. 49 can be broken up into 7 and 7, and neither of those can be broken up further. So we have 2, 7, and 7. A pair of 7s can come out of the square root, and the 2 will stay inside the square root because the 2 does not have any friends to go hang out. Now, something to keep in mind: if you've broken down a square root before, like we now know that the square root of 75 equals 5 square roots of 3. We know these are equivalent. If you've already broken it down, you don't have to keep breaking it down. So when you're breaking some of these things down, ask yourself, have I already done this before, and can I skip some of these steps? The square root of 75 and the square root of 98 are very common, and I believe both of these appear on our paper. And so you can kind of skip ahead by using some of those common things. So our steps to adding and subtracting radicals are right here. The first is to simplify the radical if possible. You cannot combine like terms if you have not simplified. So the first thing to do is to simplify. Now, if you can't simplify, or if you've already simplified, your next step is to combine like terms. You are looking for like terms that have the exact same square roots. So for example, problem 1, we have 4 square roots of 7, and we're adding 5 square roots of 7. So because these have the same square roots, the same number under the square root, they are both talking about square roots of 7, we add the numbers in front. 4 plus 5 is a total of 9 square roots of 7. And that's all you have to do. So let's look at problem 2. We have 8 square roots of 11. We're taking away 2 square roots of 11. So if you want, you can rewrite the numbers in front. So we're taking 8 square roots of 11 and subtracting 2 square roots of 11. So we're really only doing the operation in front, keeping the square root exactly the same. So 8 minus 2 is 6 square roots of 11. You can think of square roots of 11 as like x's, y's, apples, oranges. We have 8 oranges. We're taking away 2 oranges. We have 6 oranges remaining. You wouldn't take 8 oranges, subtract 2 oranges, and end up with 6 bananas. So make sure you keep your square roots exactly the same unless you are simplifying them. So problem 3 has been done for us. We've underlined the square roots of 3 and squiggled the square roots of 2. So we have 7 square roots of 3. We're taking away 1 square root of 3. 7 minus 1 is 6, and you keep the square roots of 3 exactly the same. The square roots of 2, we have 2 square roots of 2. We're taking away 3 square roots of 2. 2 minus 3 is a negative 1, and again, the square roots of 2 stay exactly the same. When we write our answer, we have 6 square roots of 3, taking away 1 square root of 2, and that's our answer because square roots of 3 and square roots of 2 are not the same. So for problem 4, we have 3 square roots of 6 and 5 square roots of 6. Square roots of 6 cannot be simplified, so 3 plus 5 square roots of 6. 3 plus 5 is 8, so we have 8 square roots of 6 total. We have a negative 2 square roots of 13. 13 is a prime number that cannot be simplified, and so we just leave that as minus 2 square roots of 13, because square roots of 6 and square roots of 13 are not like terms and cannot be combined. Now, we've done problem 5 for you as well. You can see it's a lot more work. So the first part that we have to do, this is where step 1 comes into play. If possible, we have to simplify. The square root of 192 needs to be simplified. So the square root of 192 is broken up into 6 and 32. 6 is broken up into 2 and 3. 32 is broken up into 4 and 8. 4 is broken up into 2 and 2. 8 is broken up into 2 and 4. And 4 is broken up into 2 and 2. So we have 2, 2, 2, 2, 2, 2, 3. So those are all listed here. Again, 2, 2, 2. 2 times 2 times 2 comes out to 8. So 8 total comes out. So 8 was 2 times 2 times 2. So we have 3 sets of 2. And then a square root of 3 left. Now from the very beginning there was this 5 in front. So front times front, 5 times 8 is 40 square roots of 3. So that has now been simplified, 40 square roots of 3. So I replace 5 square roots of 192 with 40 square roots of 3 because that's what I just simplified it to. And then I haven't done anything with this yet, so that just gets rewritten, minus 7 square roots of 3. Now, because I have square roots of 3, square roots of 3, 40 minus 7 is going to give me my total number of square roots of 3. 40 minus 7 is 33 square roots of 3 total. Now remember, in your calculator, you can type this in exactly like you see it. 5 square roots of 192 minus 7 square roots of 3. And get this ugly decimal. We will compare it to 33 square roots of 3. Same ugly decimal. So, if possible, simplify your square roots first. We simplified 5 square roots of 192 into 40 square roots of 3. Then, because we have like terms or like square roots, we subtract or do whatever the thing in front says. Okay. Now, when I look at problem 6, square root of 3 can't be simplified, but the square root of 75 we simplified up here. So remember, the square root of 75 is simplified to 5 square roots of 3. So I'm going to replace this with 5 square roots of 3 because that's what we know it is from the top. So this was simplified in the bell work. Okay. So my next step is going to be to simplify this part first before I combine it. So I'm not doing anything with the number in front. Negative 2 times 5 is negative 10, and the square roots of 3 stays the same. Now, square roots of 3, square roots of 3, same terms, so I do what the numbers in front say to find my total number of square roots of 3. 5 minus 10 is negative 5 square roots of 3. And again, you can type this in exactly like you see it to compare your answer to make sure we've done it correctly. And I'll compare that to my answer. And I have the same ugly decimal. Also, remember at any time along the way you can check, like -2 square roots of 75. Is that comparable or accurately the same as -10 square roots of 3? At any time along the way, you can make sure that you've simplified things correctly by making sure the decimals are the same. You can't just write down the decimal answers because you will not get credit for that, but you can use that to make sure that you have simplified things correctly. So for this really ugly problem, we can see there's a lot going on. So let's talk it through piece by piece. Start working from left to right. 25 square roots of 2. Well, the square root of 2 cannot be simplified. There's nothing I can change here. So I personally just rewrite my thing all the way down at the bottom, 25 square roots of 2. Now the square root of 27 in this middle term can be simplified. So we have 3 and 9. 9 can be broken up into 3 and 3. So I have a pair of 3's that will go outside, a 3 that will stay inside. So the square root of 27 is simplified to 3 square roots of 3. The 2 from the front was brought down because you can't ignore that. 2 times 3 is 6, and the square root of 3 stays inside the house. So this all simplifies to 6 square roots of 3. And remember, if you want to double check, 2 times the square root of 27, is that the same as 6 square roots of 3? My decimals are exactly the same. So I rewrite that simplified answer all the way down at the bottom. And then square root of 98, we did that at the front. It was 7 square roots of 2. Remember, we broke it up into 2 and 49. 49 is 7 and 7. 7 comes out front. 2 stays in the square root. And then bring down the -3. So -3 times 7 is -21. Square roots of 2 stay the same. Now, because I've simplified all of them, so that was step 1, simplify. Now that they're all simplified, I combine any like terms. So I have 25 square roots of 2, and I'm taking away 21 of them. So 25 minus 21 is 4 square roots of 2. And then I just add in the 6 square roots of 3 because there's nothing to change that. And again, if I wanted to compare, I could type in this whole long ugly thing into my calculator. So 25 square roots of 2 plus 2 square roots of 27 minus 3 square roots of 98 is this long ugly decimal. 4 square roots of 2 plus 6 square roots of 3. Same ugly decimal, both written differently though. Remember, you cannot write the decimals as your answer. So we have one more problem to do. 7 square roots of 3 cannot be simplified, so I simply rewrite it. -4 square roots of 6 cannot be simplified because 6 cannot be simplified, so I rewrite it. Now 48 can be broken down. 48 is 4 times 12. 4 is 2 times 2. 12 is 2 times 6. 6 is 2 times 3. So I have 2, 2, 2, 2, and 3. 2 sets of 2's coming out, so 2 times 2 is 4. And then the square root of 3 staying inside. I also had a 2 from the beginning, so 2 times 4 is 8. Square roots of 3. So I'll rewrite that down here because I have simplified. And then 54 can be broken up into 6 and 9. 6 is 2 and 3. 9 is 3 and 3. So I have 2, 3, 3, 3. So a pair of 3's coming outside. 2 and 3 staying inside the square root. 2 times 3 is 6. And then out front, I had a -6 originally. So -6 times 3 is -18. Square roots of 6 stay there, so I've simplified that. And remember, if you're not confident, you can check all of these The first two you don't need to check because we haven't done anything with them. But I can compare negative 6 square roots of 54 with negative 18 square roots of 6, same ugly decimal. 2 square roots of 48, how does that compare with 8 square roots of 3, same ugly decimal. Okay. So from here, I'm working with this. I have 7 square roots of 3 plus 8 square roots of 3. So 7 plus 8 is a total of 15 square roots of 3. I have negative 4 square roots of 6 minus 18 square roots of 6. Negative 4 minus 18 is negative 22. And remember, you can check that at any point. Negative 4 minus 18, negative 22. So for my answer, I have 15 square roots of 3 and minus 22 square roots of 6. And again, if I wanted to, I could plug in this really long start and this answer at the finish, but for the sake of time, I've already done that a couple times, so you should know how to do that.